Hello, good morning. This system is a compressor system, older compressor system, which task needs to improve the capture of input variable and output variable, but to study by computer. Let me to show you summarized way the system. It is composed by a camera, a balloon to store gas air specifically in this case. This is an emergency valve, this is a main valve which open and close. This channel in order to measure the pressure of the air inside. Now it's maximal opened. This is the reason why the pressure level inside the camera is 0 bar. The maximal value showed by this transmitter is 64 liters per liter per minute. This is the compressor which helps to obtain changes in the pressure level of the system. The mechanical movement transmitted to the system is this DC motor, which transmits revolutions per meter in the relation to per watt. This is the speed for the compressor or send to compressor, and the trouble is here. It's not correctly shown, and the task is design or what designs hardware in order to capture all the measurement variables, output variables and input variables in general, and integrate by computer in order to study this system. Temperatures around the compressor are near the compressor 40 degrees because it increased concerning the changes of this pressure level, and also the heating transmission during the process around the compressor. And around the system temperature 1 before to enter to the compressor air, talking about the air, flow air, and when it leaves from the compressor, before and after. The maximal value of this of the flow is showing here, 67 liters per minute, and the pressure this equivalent voltage, because the sensor has an equivalent voltage, and it is transmitted and calculated in physical parameter for flow. The same from the pressure sensor, from voltage value to pressure units, okay, in bars. And finally, the speed of the compressor, 500 RPMs more or less from this sensor value, and torque in newtons meter. Well, where is the trouble? The trouble means that we designed it, first of all, let me to reduce noise. Oh, Elvis pressed. Now, the trouble is how to integrate the system, because we have an older system which works with own input variables and output variables, temperature, 3 points of temperature, the sensor to measure the torque, and also the RPM. Both are obtained by excitation input variables from electrical signals, and the output variables are given by flow and the pressure. Okay, it has own system, own sensor how to obtain this. Nevertheless, older system has trouble in order to be updated, in order to integrate with new sensor. Why is the trouble? Because if we want to go from one point measurement to another point of measurements and so on, like is represented in this graph, color blue, okay, linear desired response, but we have all the response from the sensor. Why everyone has own directions, and why is possible that we will be around the desired measurements? Why? Because every sensor in static behavior, it means when it is calibrated outside the plan of this system, it has own measurements from own characteristics. Okay, from own characteristics, because the material as it is designed. But when we integrate sensor with the system, if we add or join this own characteristic from sensor with the a process characteristic, of course we will have a trouble. Of course we will have delays. Delays which you can say, of course, okay, it is only analyzed in transient response, in the response time, for example. But it is not a trouble, it is not a matter in steady state. Okay. But remember that every point has own directions due to own characteristics, due to own response time. Well, if you summarize, you can obtain a mathematical model how to integrate this response time, talking about looking for the response times. And when we want to get this steady state, for example, one steady state, another steady state of the pressure, for example, to measure the pressure, but all the sensor to get pressure, to get flow, own system. The older system has a response time error. In this context, has a response time R1, R0. But now we have another integrated system, okay, which has another response, perhaps more fast, perhaps more slow, depending the linear operating work. And what happens if this steady state, delta 1 and delta 2, are near response time? You will have a trouble. Why? Because your system is looking to get the change to achieve steady state, but you will not give to the system enough time to get the change. And you can check these troubles because while you see the sensor, for example, from pressure level in the bulb, and compare with computer, of course, will be different. But why? Because we didn't linearize the system? Because we didn't obtain correctly offsets from this point to this point? What happened this? Okay, this is the trouble because all characteristic of the system. No. If we integrate the system, we must remember that, of course, the dynamic process, not in the steady state, because in the steady state, while this time is enough bigger than response time, okay, we will never see the changes. What happens in this condition? Be careful, be careful. So, how to avoid this? The solution is proposed by an adaptive integrated sensor. It implies by computer we can get an adaptive coefficient in order that sensor will measure this parameter and have own coefficient in order to adjust this line, red line, to realigned color blue or desired line, which comes from the own sensor at the beginning measurement, as it machinally measured 30 years ago. But now we integrate another system with another sensor. Of course, we will obtain this color red line. The task is adapt or adjust also to linear blue. Another proposition which is so interesting because now step by step nanosensors start to be integrated to this system, we can avoid this software work because of nanosensor has so fast changes, so fast response time to be adaptive in systems. So in article proposals, after this video will be explained a bit more, after to show the solution of this trouble. Also will be written and proposal articles concerning how to integrate nanosensor in this system, because new sensors like this are not enough now. We need sensors which response time can be enough short to be adaptive to older sensor which response time are bigger than older sensors. And also, so linear response and compensations like it is obtained by nanosystems nowadays. In these articles also we will show by simulation this response and to propose two response for these troubles to update older machineries to new machineries by software or what is happening to integrate with new nanosensor systems. Okay, thank you so much. See you.